Today's the day. Intel is launching their many core Xeons, the many E-core Xeons that we've heard so much about. 128 cores, 144 cores. I've got them. And we're going to do some testing. Well, I'm here in Taipei, and Intel's launching the new Xeon 6 line, starting with their fully E-core configuration, like full E-core socket. I'm not really sure what to call it, but it's all E-cores. 144 E-cores per socket. 2-socket systems. I've got the 6700E, the 6766E to be exact. That's the 250 watt configuration, as well as the 144 core 350 watt configuration. Now we'll talk a little bit more about that. It actually does make sense. Intel's showing some really interesting stuff here. But they've got two new Xeon sockets. And whether you want to get a P-core CPU or an E-core CPU, it'll fit in the same socket. It's basically just you want the 8 memory channel platform or the 12 memory channel platform. I'm starting out by taking a look at the 8 memory channel platform. That's launching first, but the P-core configurations and the 12 memory channel platforms will be launching later this year. So this is just what's launching now, which is all E-cores all the time. And this has been a long time coming. Partners have been climbing the walls to get this because this is, Intel's answer to the kind of CPU density that AMD has been doing with EPYC for a couple of generations now. And now this kind of goes against EPYC Bergamo, but also the Genoa 9554 64 core variety. 144 cores versus 64 cores. Yeah, it's complicated. I'll get to that. So the first thing to look at for this platform is, this is the new Birch Stream platform, the Xeon 6700E. It's formerly codenamed Sierra Forest. It's a forest of cores. That's how you remember that. But yeah, this is a 1 or 2 socket platform up to 144 cores, 64 cores at the low end, 205 to 330 watts. That's 8 memory channels, or you can do 2 DIMMs per channel, but you'll be limited to DDR5 5200, otherwise DDR5 6400. The extra memory bandwidth does help when you've got 144 cores. It has 88 lanes of PCIe Gen 5 and X16, X8, X4, or even X2 configurations. The X2 is actually pretty popular with the E1.S and E3.S storage, because Gen 5 storage with 2 lanes is a little easier to do electrically, wiring it to the front of the chassis, versus 4-lane NVMe. It actually does make sense for storage servers, and so this can help you with that, because hey, E-cores for storage server, it's massively parallel. Makes sense. Intel has never done a Xeon with E-cores before, and the E-cores here do AVX2, VNNI, INT8, BF16, floating point 16, and a sort of a fast up-down convert with 2 by 128-bit FPUs. So, not bad. The configuration here also has Intel accelerators, DLB DSA 2.0, the Intel acceleration architecture, the IAA 2.0, and QAT. That's 2 per socket. And so Intel hasn't locked down the accelerators or hidden those behind extra licenses. You get 2 of each per socket, basically. Now, what Intel says that the situation that their customers find themselves in is that their customers are still on Cascade Lake or Ice Lake. They're looking at systems that are 4, 5, 6 years old, and they're looking to replace them. And bottom line, this platform can replace those older platforms at a 3-to-1 ratio with the same power envelope. These E-cores perform about as well as the older, like 1st or 2nd gen Xeon Scalable, but at a fraction of the power. So you can dramatically increase your density at the same power, or you can run a bunch more workloads if you're doing a 1-to-1 system replacement, like 66% more. Now I have 2 configurations, 2 CPU configurations to look at in Quanta Cloud System. This is basically a reference platform, so this is not something that you would buy exactly, but it might be something that would be deployed in a hyperscaler. You would normally buy a system like this from Dell or HP or Supermicro or somebody like that. And the first set of CPUs is the 6766E, which is a 1.9 gigahertz base, 2.7 gigahertz all-core boost. Yeah, Intel has actually simplified the way the boost works, because they know that hyperscalers basically want to run this full tilt 24/7. Like, there are off-roadmap SKUs that we've looked at in videos on this channel in the past, where Amazon or somebody said, we want a CPU that'll just turbo or be a certain speed just all the time, because this thing is going to be busy all the time. If it's not busy all the time, we're not making money on it and we're failing at business. And so we don't want that. We just want it to be able to turbo all the time. And so 2.7 gigahertz turbo all core all the time. Yeah, you'll see that on the 6766E. There's a 144 core and a 250 watt power envelope. We're also going to take a look at the 350 watt power envelope 6780E. It's still 144 cores, but this is a 330 watt power envelope. So you can get quite a bit more performance. So for an extra 80 watts per socket, you can get a pretty significant performance uplift. But again, Intel says that their customers say that they're basically fixed in their power budget and their deployment. And so if they're doing a 1-to-1 chassis replacement for 5-year-old chassis, 250 watts is what their power budget is per socket, and that's what they got to run with. Now let's get into our benchmarks. This is our Intel Software Development Research Platform machine. Now in this configuration, as servers trend ever toward more wattage, it's going to use a little less than 1,000 watts. This is actually the most power efficient Intel CPU has ever put out at this scale. Not just got the core count, it's also got the low power consumption. It's also important to note this is not exactly a top-of-stack configuration. This is meant to be mainstream, mass market. This is what hyperscalers are deploying in tens of thousands of unit quantities. This is going to run your web workloads. This is going to run MongoDB and MySQL and Apache Web Server and Redis and maybe some light AI workloads, maybe some QAT accelerated workloads, because we do have accelerators. We do have accelerators on this platform. There's a lot to unpack here. 88 PCIe lanes, 128 cores, 144 cores. Now the E-cores, those are single-threaded. So the 9654 from AMD, the 64-core EPYC, is going to be one of our comparison CPUs for this platform. 64 cores, 128 threads versus 128 cores, 128 threads. It's a very interesting breakdown. Our test platform gives us a lot of test flexibility. We have a lot of NVMe connectivity at the front. We've got some of our 88 PCIe lanes routed to the back. This is a dual socket configuration, and we can rock 256 gigabytes of memory for all of our testing per socket. We also have 2 OCP3 slots and the modular out-of-band management interface, which the cloud service providers love because they can source those and configure those however they want. We do have dual 2700 watt power supplies, so I can add some L40S GPUs to this or something like that and do some AI testing. Today we're focused on performance and features because this is the first Xeon launch from Intel, Xeons with E-cores. I feel like there's a cat in a hat reference there somewhere. All right, so this is the geometry problem when we start talking about results. And I'm just going to cherry pick some results. Our full results are uploaded to openbenchmarking.org. I'm sure Phoronix is going to have lots of stuff. I used Docker and Phoronix, the Phoronix test suite, for doing a lot of the testing here. Docker spinning up microservices and the Phoronix test suite for running a bunch of other tests that are wrapped up in there. But here's what's really interesting. And let's go back and look at the actual layout of these chips. So 2 sockets, I said 6700 and 6900, 8 memory channels and 12 memory channels. The 8 memory channel configuration here, look at those I/O dies. There's 2 of them and they're really small, and they flank either side of a 144 core E-core die. Now we know that from the pictures here there are other layouts coming. One of them is going to be a 2-die layout that is P-cores. That's not available yet. And then in the 6900 socket, you could actually have 2 of these 144 core tiles and then your I/O die. And that's in the 12 memory channel configuration. Okay, that's great. This is pretty genius. It's very similar to AMD's approach with Zen 4 and Zen 4C, Genoa and Bergamo. Basically, they're using the same socket and platform, but they're bringing up 2 different CPUs on the other side of an I/O die. That's what Intel has done here. They have 2 I/O dies that are identical between these 2 sockets, but that are configured differently in the 2 sockets. And the tiles are the same. So like the 144 core tile in the 6700 socket is the same as the 144 core tile in the 6900 socket. And the P-core variants are coming later. But for E-cores, it's really interesting. So versus the Genoa 9554, that's 64 cores on 128 threads, Intel's per core performance is just a little bit less averaged across the whole socket. So you're taking like, a hyper-threaded core for the comparison here, which is not necessarily an apples-to-apples comparison. We'll come back to that. Don't worry. And we're looking at the power efficiency, and it's like, okay, across the board, geo mean, Intel's at like 93% of the overall computational speed per socket, which is breathtakingly impressive. In terms of power efficiency, Intel is edging out power efficiency. Yeah, Intel's 3nm foundries have been busy. It makes sense that this is the first thing that we see on Intel 3, and Intel 3 has got some teeth, it looks like. Hugely very impressive. But the 9554 is not the only CPU in AMD's lineup. Now keep in mind, the 6766E, is a 250 watt configuration. 250 watts, mind-blowing power efficiency here. If you reconfigure and you reset up your tests, and this was turning into, I haven't had a lot of time with this system, and so the systems that I had planned to test, and then after getting the first set of results in, I was like, oh, we need to reconfigure this. So switching over to a single socket Bergamo, that's Zen 4C, AMD's energy efficient cores, 12 memory channels, and configuring it CTDP for 400 watts. There's a lot of variables that you have to juggle here, but in a lot of cases, I can meet or beat Intel's performance with our 128 core, 256 thread part. Now where that falls apart is microtransactions, microservices, online application processing, and lots of little tiny virtual machines. If you create a Docker instance, so like one of the tests that I haven't documented super well, but one of the tests was creating lots and lots and lots of little environments with Docker Compose that consisted of a front-end Nginx proxy and then an application container running Python or Ruby or Node.js, and then like Node.js for an application, and then Nginx for proxying, and then a database layer, PostgreSQL and MySQL. And each little container is its own sort of self-contained universe that's getting simulated traffic. So I have one container that's generating all sorts of simulated traffic, and then I have everything else that's running on all those little containers. And Intel 6 shreds on that kind of a workload. It seems like these are purpose-built for hyperscalers. And so for that kind of a hyperscaler benchmark was really interesting. I really thought I would be able to distill down that type of test into some kind of equivalent in the Phoronix test suite, but I didn't really find anything that was super equivalent. So when you dive into the benchmark results here for things like PostgreSQL, and you look at that versus even Intel's, prior Emerald Rapids, I did a test against a nice super microsystem with Emerald Rapids Platinum CPUs. You look at it and it's like, wow, this doesn't really perform quite as well. And that's because the way that this is architected, the E-cores don't really have access to that much memory bandwidth individually. But that's actually better from a load balancing perspective so that you don't have a few really busy cores starving out all of the other cores and making the experience worse on other cores. At the same time, that doesn't look great in benchmarks because a lot of these benchmarks don't really fully load the system, or in order to see the difference, you have to get the system loaded between 90 and 100% load in order to experience, how the system grinds to a halt under that load. But it's, again, back to the Bergamo 128 core. So Bergamo 128 core with 12 memory channels, in a lot of cases, for the microservices and for everything else, it comes close to performing as well as the Intel Xeon 6. But it seems to be able to do so with 12 memory channels instead of 16, 2 sockets of 8 memory channels. And so I think that the spread here is both less than and greater than it would appear. And this is what I mean when I say you really have to consider the geometry of your workload, because you may be able to replace a single socket system or a dual socket system with a single socket system that may actually be better for your workload. Or if you're a hyperscaler, sticking with 250 watt sockets may make all the difference in the world for having a consistent end user experience where no one person is going to be able to monopolize. The other thing is that Intel, for their part, the amount of power usage per core is basically flat. So even though it can turbo to 3 gigahertz, at the wall, this Quanta system, which is not optimized for power efficiency, never really seemed to draw more than like 650 watts total system power. Now granted, I've only got a couple of drives in there, but that tells me that the telemetry that I'm getting from the socket and everything else, these CPUs really are staying close to or under their 250 watt TDP, which is interesting to say the least. There were a couple of tests where I could get the system to pull more like 650, 700, 800 watts from the wall, but within 10 or 15 seconds, it would back off. So that's something that I need to investigate. I haven't had enough time with this, and this is also Like, I'm going to have to borrow a Supermicro chassis or a Taiwan chassis or a Gigabyte chassis that is like a production shipping chassis, because when I asked Intel about that, they said, maybe don't use this example of like this test chassis for power consumption measurements. Like, you can use the CPU telemetry, but at the wall, it may not be like fully optimized yet or fully configured yet, and that their OEMs had done a better job with the power efficiency. So that's something else to consider. We look at the Phoronix test suite for things like, PHP micro benchmarking and SQLite micro benchmarking and that sort of stuff. It really shows how far Intel has come gen on gen when we're talking about a fully loaded system configuration. If you just look at the burst performance versus, say, Emerald Rapids, it doesn't look as impressive, but that's not really real world experience using this. And that's why this is going to be a difficult platform to benchmark. I would not have expected this much gen on gen improvement from the E-cores that Intel is offering. Like, I can't understate the 250 watts here. The power efficiency is competitive with AMD's Zen 4C cores, but AMD could probably offer a Zen 4C configuration at a price point and a power consideration that would be a direct answer for this. But right now, the answers from AMD are indirect, or crazy people like me messing with the CTDP and the system configuration to try to come up with something that is an apples to apples comparison when we're talking about performance per watt. But be sure to check out our full Phoronix benchmark results and the other interesting stuff in there, like OpenVINO and everything else performs really well. These E-cores don't have AVX512, but the VNNI and other stuff does seem to help with the acceleration, and media encode and all that is very strong performance from these cores, but it's consistent performance across the board. It is a linear loading. As the system goes to 100% load, you don't see exponential increases in the amount of time that it takes to service individual requests, which is I think indicative of a very solid architecture for the overall system, which is great. Good job, Intel. Now, right off the bat, the 9554, I get why Intel wants to compare that. It is 64 cores and 128 threads, but as this is an E-core platform, hyperthreading is not a thing. We have 144 cores and 144 threads. If you look at it versus the 9554, the 9554 is performing very similar, maybe slightly behind, maybe slightly ahead, depending on the workload, but in only 64 cores. However, the power envelope is a little bit higher. So in a dual processor 9554, you're using a little bit more wattage per socket versus the 250 watt configuration that we start with. And so you end up with about a 30% performance per watt advantage on the Intel side. This is a really interesting result, actually. 144 cores versus 64 cores. If you're using the system and you have a bursty workload where you're not going to have all the cores completely busy all the time, then you would probably benefit from the higher performance of the 9554 cores. But the 144 cores that you have can deliver. And so if things parallelize really, really well, this level of performance in 144 cores in this configuration looks really good. If we stop the benchmarks for a second and say, okay, is this, how is this actually configured in silicon? Intel told us that this is one giant 144 core compute tile, and you've got 2 IO dies. Now, the other socket that I mentioned, the one that can do 12 memory channels, you can have the same compute tile on a different carrier that's, more pins because 12 memory channels, but you can have 2 144 core tiles plus your IO tiles, and then that will really take you off to the races. But that platform's not launching yet. We don't really know any details about it, but know that it's in the roadmap. Now, if you wanted to run performance cores, it'll still work in either socket, 8 memory channels or 12 memory channels. You can get several different configurations, even up to 128 performance cores in this if you really want to. And the performance core layout could be a single piece of silicon with a relatively low number of performance cores, or 2 or 3, all the way up to the 12 memory channel Xeon platform. So Intel gives you some options, but it's the same sockets, pin compatible. It's just is it the 8 memory channel platform or the 12 memory channel platform. You get some extra PCIe lanes and some extra connectivity there, some other stuff that Intel is announcing, but again, hands-on the 8 memory channel platform here. Now, me being me, I decided to go off script a little bit. I've got Bergamo. It's 128 cores. The 128 cores, 256 threads. It's not really exactly an apples to apples comparison. Also, CTDP on that CPU, 400 watts. But the question on my mind was, can 128 cores, 256 threads, match the performance of dual 144 cores, a two-socket system? Because that would sort of tip the power scale, back in AMD's favor versus Intel. And the results were mixed. For some workloads, that can work, but Intel is in a stronger position in terms of media encode and is maybe in a stronger position when we're talking about OLAP type stuff, so like a MySQL or PostgreSQL database. Intel with just, 288 cores on this platform that can be off doing things, that's better than a hyper-threaded core in a lot of scenarios. There are some scenarios where the hyper-threaded core does actually seem to do better. And the fact that, your platform here is a single socket 128 core Bergamo CPU, Zen 4C, it really just underscores how well, AMD can hold its own with this platform, because, Bergamo has been out for like a year, and Genoa has been out for well over a year at this point. And so Intel is just entering this, this is their platform. And Intel still has to launch stuff in this family through the end of the rest of the year. So this is really, really, really intense competition on Intel's part. But Intel coming out with their new process node, their new ultra efficient process node, and being able to deliver this much performance out the gate in 144 cores per socket is extremely impressive. This is perhaps a good sign of the future for Intel. It would be nice if there was more of a performance gap here so that Intel could pull ahead even a little bit more, just depending on the benchmark and depending on your workload, because now, as a system administrator or system architect, you really are going to have to know the geometry of your workloads. You're going to have to put in a lot of work to figure out, okay, is it going to make sense for me to use this? Is it going to make sense for me to use this on the accelerators that Intel offers? Because you get 2 of all the accelerators per socket, a total of 4 in a 2-socket system. But then if you're a hyperscaler, it's like, how do I divvy up in-memory analytics among all of the tenants that are on this machine? Or how do I divvy up QAT or something like that among all of the tenants that are on a 288 core machine versus, the Zen 4, the Zen 4 platform doesn't have any accelerators like that, but you do have a little bit more performance per core, but now at a little bit of a power deficit, but not really, depending on what kind of a job you're doing, because 1 socket might get the job done versus 2 sockets. And so it's really getting interesting to do an apples to apples comparison, job for job. But Intel making this much of a performance gain with dramatically reduced power utilization, very impressive. And if they're able to pull this off with their P-core variants, the same level of efficiency and the same performance per watt over on the P-core side, then Intel's going to have a part number for whatever workload that you want to run, because some things don't really parallelize all that well, and it's better to have fewer high performance cores or bursty workload stuff. And so it's really interesting, if a bit dicey situation. So if you do have a little bit more of a power budget and you can go into the 330 watt per socket, that does unlock a whole other level of performance. You can see in our comparison benchmarks for the types of web workloads and everything else that we do that, if you can afford a couple of hundred more watts at the wall for your system configuration, then this is worth it. But I get why Intel was sort of underscoring the 250 watt part. I mean, at 250 watts, that really is best in class power efficiency. It is shockingly impressive from Intel, especially given the history of CPUs since Cascade Lake. This is a dramatic improvement. And this is Intel's silicon too. Intel 3 is coming up pretty strong. They tell me that Intel partners are pretty much ready to ship systems with this configuration, which is why this is launching now. And this is a story for Intel that would not have changed in 3 months with the availability of the P-core parts, which are coming later. So it makes sense why Intel is launching this now. I think also that we're going to see, AMD launch a new platform. I mean, if they keep their cadence the next 6 months, 8 months, something like that. And it'll be really interesting to see what AMD comes up with in response to this, or how they tweak and tune, or maybe they'll reshuffle some SKUs or something like that, because Zen 4C is still quite formidable in 2024. This is only good news if you run a data center or you need to buy a lot of servers. This is there's some aggressive posturing, and there's some aggressive pricing, and there's some aggressive performance gains, performance per watt and performance per unit compute. So it's pretty exciting in 2024. I'm Wendell, this is Level 1. This has been a first look at Intel Xeon 6 platform and the new CPUs from Intel that are part of a new tile process, and just Intel 3. There's a lot going on here. But if you have any questions or I missed anything, you want me to run a test with your workload, let me know. Hit me up in the forums. I'm signing out, and I'll see you there.